So, hello everyone. Today I am going to present a next generation firewall integrated with an intrusion detection system built completely from the scratch. This is not just a basic firewall that blocks port. It is a multi-layered security pipeline that uh, captures packet, analyzes behavior, that makes intelligent decisions automatically, blocks attackers, logs forensic evidences, and visualizes everything in a real-time dashboard. The goal of the project was to deeply understand and implement how modern enterprises firewall operate internally, from packet capture to a automated response. So I will walk you through this presentation, and using this presentation I am going to explain you nine stage means nine layer implementation of this firewall. Also I will walk you through a a demo of this project in the terminal also and in the dashboard also. So let's move to the agenda. Now let's talk about the agenda of our presentation. So in this presentation I will first explain the security problem. Then I will walk you through the system architecture. After that I will explain the complete 9 stage pipeline, how a packet flows through the system. Then we will look at the operations and visualization. And finally, I will conclude with future scopes. So let's move to our introduction. So let's see what was the problem with the traditional firewall. Traditional firewall rely on static rule lists, blocked IPs, blocked ports and blocked protocols, but attackers don't behave statically. Modern attacks like port scanning, SYN flooding and Reconnaissance probing are behavioral in nature. A static firewall cannot detect patterns that evolve over time. So the real requirement in modern network is not just filtering, it is intelligent adaptive defense. Now we will see the 9 stage security pipeline. So the solution is the 9 stage security pipeline. To address this limitation, I designed a 9 stage security pipeline. Instead of relying on a single filtering layer, the system performs packet capture, data normalization, static policy enforcement, behavioral detection, correlation and decision making, automated mitigation, multi-format logging, real-time dashboard visualization, performance monitoring. So this transforms raw network traffic into the actionable security intelligence. So now we will look at the project architecture. So now we will go through the project architecture. The architecture is modular and layered, similar to the enterprise-grade firewall systems. Each component performs one responsibility. The capture layer handles ingestion, the firewall engine enforces policies, the IDS engine detects abnormal behavior, the decision engine correlates output, the logging system stores events, the dashboard visualizes security activity, the monitoring system ensures stability. This layer design ensures scalability, maintainability, and clarity of the operations. So now I will walk you through the system architecture flowchart. From there we can understand that how packet passes from the first layer to the last layer. So let's move to it. This slide represents the complete end-to-end system architecture flow. It shows how a single packet travels through multiple layers of security processing, from ingestion to final decision and visualization. The design follows a layered and correlated security model similar to enterprise next-generation firewalls. So now let's come to the flowchart. Packet ingestion. The process begins with packet ingestion. The system continuously listens to the network interface and captures live packets in real time. At this stage, packets are raw binary data. No analysis is performed here. The priority is fast and efficient ingestion without packet loss. Now, let's come to the stage 1, capture. In stage 1, captured packets are immediately pushed into a buffer queue. This follows a producer-consumer architecture. The capture layer produces packets rapidly while the processing engine consumes them asynchronously. This ensures stability even during traffic spikes or attack bursts. Now, we will see the security logic zone. After capturing, packets enter the security logic layer. This is where intelligence begins. The packet now undergoes structured analysis across multiple engines. So, we will see stage 2 normalization first. First, the packet is normalized. Raw network data is converted into structured information such as source IP, destination IP, protocol type, port numbers, and TCP flags. This structured format ensures consistent and reliable analysis across all subsequent stages. So, we will go to stage 4 directly after the stage 2. Here, immediately after normalization, the packet is analyzed by the intrusion detection system, which is written combined in IDS as IDS engine in normalization. In this diagram, normalization and IDS detection are grouped together within stage 2 under the security layer logic. However, logically, this represents stage 4, the behavioral detection phase. The IDS performs stateful analysis, meaning it tracks the pattern over the time. It detects behavior such as ping scan, port scanning patterns, SYN flood attempts, ICMP flooding, malformed packet anomalies. Unlike static firewall, this stage understands the activity across multiple packets and time windows. Now, we will move to stage 3. Stage 3 is firewall rules. In parallel to behavioral detection, the packet is also evaluated against static firewall rules. This includes checking blocked IP addresses, restricted ports, and blocked protocols. This represents traditional rule-based filtering. It is deterministic and policy-driven, unlike the adaptive IDS layer. Now, let's move to stage 5, decision engine. The output of the firewall engine and the IDS are sent to the decision engine. This is the core intelligence of the system. Instead of relying on a single indicator, it correlates multiple signals before making a final judgment. For example, if firewall allows traffic but IDS detects suspicious behavior. Also, we have another example. If repeated alert occurs from the same source, the decision engine escalates the threat level accordingly. It also maintains history for each source IP, enabling adaptive response. Now, we will go through the malicious decision node. After correlation, the system evaluates the critical question: is the traffic malicious? The decision is based on policy violation, behavioral anomalies, repeated suspicious activity, and escalation threshold, which we have seen in stage 2, stage 3, 4, and 5. From here, the architecture branches into two paths: yes and no. If yes, if the malicious traffic is yes. If classified as malicious, the system triggers automated responses, which is stage 6. The source IP is dynamically added to the blacklist. Future traffic from this source will be blocked at the firewall level itself. This ensures long-term mitigation, not just temporary alerting. So let's see about the stage 6 automated response. Stage 6 implements real-time defensive actions. This includes dynamic rule injection, IP blacklisting, and escalated threat classification. This creates a feedback loop. The system strengthens itself against repeated attackers. Now, we'll come back to the malicious node again, and if the malicious is if it points to no, then it is a legitimate traffic. If the traffic is legitimate, it is allowed to pass normally. However, it is still logged and forwarded for monitoring and visibility purposes. So it will go to stage 8, SOC dashboard. SOC stands for Security Operations Center. All events, whether allowed or blocked, are sent to the SOC dashboard. This provides real-time visibility into traffic volume, attack types, severity level, allowed versus blocked statistics. This mirrors real-world security operations center workflows. Now, we will go to stage 9, performance monitoring. Independently of detection pipeline, stage 9 continuously monitors system performance. It tracks CPU usage, memory consumption, and packet rate. This ensures that security enforcement does not compromise system stability. So, this architecture represents a layered, correlated, and automated security pipeline, transforming raw network packets into intelligent, adaptive, defensive decisions in real-time network. So, as we just discussed in detail, this diagram represents the complete end-to-end flow of the system from packet ingestion to automated response and dashboard visualization. The remaining slides break down each of these stages individually. However, since I have already explained the full pipeline verbally, I will not be repeating the same explanation again. On the upcoming slides, I have summarized each stage separately for clarity. I have also mentioned the corresponding file names for each stage, so if anyone wants to explore the implementation details, you can directly access the relevant module. The complete project source code is available in the description. You can go through the code structure there and explore each stage in detail. So now I will walk you through the whole demonstration of the project, which I have explained you in the form of system architecture. I will be showing what is the action, what are the actions of the which stages. So let's see that. So I have used two OS specifically. As a victim, I am using Ubuntu OS, and the second is the Kali Linux, which is as an attacker. Okay. So first of all, we will check the IP addresses of both the systems. Okay. So 163.129 is the IP address of this. Okay. Here I have checked the 163.128. Okay. So both of them are on the same network. Now let's clear this first. Okay. I will be running the script, and let me tell you first that we will go through the four types of attack. Let me show you. Okay, dashboard and there is detection. Okay. So first here we will go to the land attack. Source IP is same as the destination IP, and the second one would be the SYN flood attack. Third one would be the port scanning attack, and the fourth one would be the ICMP flood attack. So here I have implemented the logic of that for mitigating the attacks. Okay. So now let's go to the terminal and okay. So let's run the main script. So here is running. See the monitor host IP detected as 192.168.163.129, which we have checked previously. So here the normal packets are been allowed. Now first we will go through the SYN flood attack, which I will be doing it from the attackers OS, which is the Kali Linux. Now I will write sudo hping. Hping is the command for doing the ping attack through the different protocols. Here we will be doing it through TCP as it is SYN attack 192.168.163.129. Okay, that's P. Here P is the port number and we have specified the port number as 80, and I have used the flood as a argument, which means these packets would be sent as fast as possible. Okay, let's enter it. The packets are, um, let's see, in the Ubuntu IP. So, I think something is wrong. Let's cancel this first. Okay, okay. See, repeated attacks, and the protocol was TCP, which was 192.168.16, and 128 was attacking on our IP. Okay, action offender added to blacklist. So this was the first. See, okay. Now as see here, alerts are being generated before before blocking the IP. Alerts are generated. So to now we will go through the port scan attack. First of all, let me remove this IP from the blacklist, which I have been stored in the JSON file. This is the JSON file where the means firewall rules, blocked ports, blocked IPs are stored by the system. Okay, so let's overwrite enter return lines. Okay, now we will perform the another attack. First, let's close, clear. We will run it again. Okay, so it has started. Now we will perform nmap. We will use nmap for port scanning, which is the common way to scan ports. And to, let's say 163.129. Okay, okay, let's use sudo because we require super user. Okay, so port scanning is started and it's done. So let's see. First of all, let's stop it. See, uh, repeated attacks and the 192.168.163.128. Okay, it is added to block list. Let's see. Action offender. So it has been detected that port scanning has been done, and due to that, the block these IPs blocked. So in very less number of time, it has sent many number of packets. These logs are getting stored also in the CSV file. Let me show you logs events.csv. Let's wait until it open. My PC is little bit slow. Okay, see, here are the types. First of all, okay. So this is the IDS alert, which has been created. See, SYN Flood attack was established, which was at the specific time, and this is the source IP and this is the destination IP. TCP allowed. See, first three of them are alerts. Due to that, three of them are allowed, and after that, every each and every one SYN Flood attack is blocked. Okay, so this was about this include which we have done first one. Now after that, let's check for the port scanning. Uh, yes, so here is the port scan. Okay. This is also been done from 163.128. From 128 to 129 IP. So this is also blocked and logs are being stored in a CSV file. Okay. Okay, so now again we will be removing the blocked IP from the JSON file because it has blocked. Okay, now we will overwrite, save it. Now we will go to the third attack, which is the ICMP flood attack. This attack uses the ICMP protocol. Due to that, only ICMP flood attack is told. Basically, this we will do using the ping. Generally we don't know that means we have been using the ping command to check that the network is established or not, but normal ping command only ensures that the network is established, and it sends the packet at a very less interval, means more interval of time. But here for flooding we will use ping sf, which means it will doing ping in the flood mode. Okay, now we will entering the IP 190.26.163.129. Okay, so this is the command for doing the ICMP flood attack. Why interval must be greater than 2 microseconds. What is this happening? Okay, let's ignore this. And we can also do ping using the, I think, due to the super user mode, normal user cannot do attack. Okay, so it's working now. Sorry. Okay, let's go. Oh shit, we haven't run the script yet. So let's stop the attack here now. Okay, the script is running and it is detecting the packets. Now we will start attacking from this again. First of all, this looks very messy. Let's clear it. Okay, so attack has started. Now see. Okay, let's stop the attack. Okay, okay. See here the protocol has been mentioned ICMP, and from which source IP is mentioned 192.168.163.128 to 129. Okay, so this was the ICMP attack, and let me show you what does it shows in the comments. Let's see the last. See, so it is mentioning that ICMP flood attack has been done. in this section. See, and it has been blocked. Okay. Now I will show you the dashboard through using which we can easily, because it is very messy to check it from uh, com command line every time. So if we have specific UI, then it would be easy for us. For this, we don't need any super user rights. I think dashboard dot UI. Okay, so it is running on the local host. Let's open it in the browser. This is the development server. Okay, I think it is not open. Okay, it has opened. See, here it is showing that the total events blocked IP is allowed, and it is showing that how much traffic from which source has been there, ICMP, UDP, TCP, okay, undefined, okay, allowed, blocked, and dropped. These are the number of IPs and which I have plotted in the form of bar graph. So this is the system performance at how means packet rate is there, memory and CPU is there. We can just cancel out anyone if we want to see specific. So that facility is also there, and this is the dashboard where time, source, destination, protocol, action, and severity is being shown. See, here from as too many requests was there from broadcast IP, so it has been blocked. See, so this is the dashboard. Also, we can, okay. Let me first try. Huh, see, here the broadcast IP is been blocked. Now I will show you live. First of all, let's see this. Okay, so I will be running the main script again, and from Kali I will be doing ping scan means CMP attack again. Okay, see it is, and here the my blocked IP is being shown. Now I have stopped it. Okay, let's stop this also. Okay, so also I can remove rule. Also I can edit the rules from here. Block IP, it will be added, it will be removed. So this is the real-time dashboard. And if we click back to dashboard, then we will be here. See, I have attacked the ICMP flood. So, and that is showing here with the time when I have attacked. So it will be easy for the operator who is using this to analyze and block the IP or remove the IP from the admin section. So this was the demonstration of the project. So that's how you build a next generation firewall with behavioral detection and automated response from scratch. If you enjoyed this deep dive into real network security architecture, make sure you hit the like button and subscribe for more advanced cybersecurity projects and demonstrations. The full project code is available in the description. Feel free to explore it and experiment in your own lab environment. Thanks for watching. Stay secure, and I will be seeing you in the next one.